There's this incredibly powerful and really relentless force that is constantly shaping our entire world. I'm talking everything from the tallest mountains right down to the sidewalks underneath our feet. It's happening all around us, all the time. So today, we're going to dig into the science of weathering.
Have you ever really wondered about that? Why do sidewalks get those cracks that seem to pop up overnight? Or, on a much bigger scale, how do these massive solid mountain ranges get their rugged, broken shapes? Well, the answer points to this one powerful process that's going on everywhere, all the time.
And that culprit, the force responsible for all this slow-motion destruction, is a process called weathering. You can think of it as the silent artist and demolition expert of the natural world, and it is constantly reshaping the face of our planet.
So what is it, exactly? Well, at its core, weathering is simply the process that breaks down rocks at the Earth's surface. It's all about taking big rocks and turning them into smaller rocks, and then into even smaller bits like sand, silt, and clay. It's really the very first step in a much, much larger geological story.
Okay, now here is the golden rule. This is probably the most important thing to remember about all of this. Weathering is only about the breakdown of rock. It does not move the pieces. That's a whole other process called erosion. So think of weathering as the hammer, right? It's not the conveyor belt that carries the broken pieces away. It just does the smashing.
So, what are the tools in weathering's toolkit? It's a surprisingly diverse list, actually. You've got the really obvious forces, like water, wind, and ice. But then there are also these more subtle agents, like just the simple daily change in temperature, or chemical reactions, and even living things. Everything from tiny bacteria to giant trees.
All those things we just mentioned, they carry out their work using two main methods of attack. You can kind of think of it like this. Physical weathering is the brute force approach. It's like taking a sledgehammer to a rock. Chemical weathering, on the other hand, is more of a subtle, molecular assault that changes the very identity of the rock itself.
All right, let's start with that sledgehammer approach. Physical, or you might hear it called mechanical weathering. The key thing to get here is that you end up with the exact same rock material you started with, it's just in smaller pieces. The actual composition doesn't change one bit.
A classic example of this is something called ice wedging. And if you live anywhere with cold winters, you've definitely seen this in action with potholes. Water gets into a tiny crack. At night, it freezes and expands with this incredible force, pushing the crack wider. Then it thaws, more water gets in, and the cycle just repeats, night after night, until a huge chunk of rock, or, asphalt, breaks right off.
But ice isn't the only physical force out there. Nope. The simple daily cycle of heating and cooling causes rock to expand and contract, and that alone eventually leads to cracks. Then, plant roots can force their way into those cracks, acting like a natural jackhammer. And then you have abrasion, which is basically nature's sandpaper, where wind and water just hurl small particles against the rock's surface, slowly grinding it down over time.
Okay, so let's move on to our second method, the chemical takedown. This is where things get really transformative. Chemical weathering doesn't just break the rock, it fundamentally alters its chemical structure, turning it into entirely new substances.
And there are a few different ways this happens. You've got weak acids, like the ones found in acid rain, that can literally dissolve certain rocks over time. Water itself can react with minerals and weaken a rock's internal structure. And a perfect example, one we've all seen, is oxidation. It's the exact same process that causes rust. So when iron-rich minerals are exposed to oxygen, they slowly turn that reddish-brown color and become flaky and weak.
So let's just recap the key differences to make sure it's all crystal clear. Physical weathering is all about the process, breaking things apart with force. You end up with the same rock, just in smaller pieces. Chemical weathering, though, is all about transformation, changing the rock's very makeup through reactions. The outcome isn't just a smaller rock, it's a completely new substance.
Okay, so we focused a lot on rocks crumbling and dissolving, which, let's be honest, sounds purely destructive. But this is the most important takeaway of all. Weathering isn't just an end, it's also an incredible act of creation.
And why does it matter so much? Well, because without weathering, breaking down bedrock into tiny particles, we literally would not have soil. And without soil, we wouldn't have plants. Without weathering, we wouldn't have the Grand Canyons, or the gentle valleys, or the intricate caves that define our world. So ultimately, this whole process of breaking things down is what makes life on land possible in the first place.
The changes can be so slow that they're pretty much invisible in a human lifetime. But make no mistake, this process is happening right now, on every single rock, on every mountain, on every continent. It is absolutely relentless, and it never, ever stops.
Which leaves us with a final, really crucial question. We've seen how this slow breakdown is essential for creating the very foundation of life, our soil. But what happens when human activity starts to accelerate this natural process? That's a critical thought to consider on our ever-changing planet. Thanks for joining us for this explainer.